Today we'll talk about angle pair relationships. This is going to be pretty simple too. It's not very abstract. It's just more vocabulary. It's a drag, but unfortunately you have to learn the words so you understand what people are saying to you. What's a complementary angle? Well, suppose you have a right angle. Now pretend those are straight. Those are rays. Use your imagination. Now if we draw another ray here, we're going to produce two angles. An angle here and an angle over here. These, I'm not even going to label them the way they do. We'll try something a little bit different. Alpha. It's a very common way to refer to an angle as alpha. Well, alpha 1 and alpha 2 are complementary. What does that mean? That means, and when we do it this way, it's safe to assume that we're talking about the measure of angle 1 and angle 2, or in this case, alpha 1 and alpha 2. And they add up to 90 degrees. That's what complementary means. Fairly simple. You just have to remember it. Suppose, on the other hand, we have a straight line. And we put a ray in there so they can form an angle. Now we have alpha 1, alpha 2. What do these add up to? Well, they add up to that straight line, which is 180 degrees. These are called supplementary angles. Up here, complementary. Down here, supplementary. Complementary, 90 degrees. Supplementary, 180. Why are they called that? Tell you the truth, I don't know. But you're going to have to memorize it. So don't forget, this is going to come up quite often. Complementary angles add up to 90 degrees. Supplementary angles add up to 180. Now, suppose I drew alpha 1 like this. And then I drew alpha 2 like this. Now they don't share a vertex anymore. Are they still complementary? Yes, they are. They still add up to 90 degrees. Take my word for it. The drawing isn't the best, but I intended this alpha 1 to be the same as that, and this one to be the same as that. In fact, this is a good time to show you that notation. When we put a little single arc in there and then put one somewhere else, that means the two angles are congruent. Say I put 2 here and 2 here. That means this angle is congruent to this angle. This angle is congruent to this angle. Actually, we do that with segments also. Suppose I had, we'll start with a rectangle, okay? You'll learn more about rectangles coming up, but you probably know what a rectangle is. And you probably know that this side and this side are the same length. So you go like that. That indicates that these two are the same. It doesn't say anything about what the actual length is. It just says that they're congruent. And over here, these two sides are congruent, so we go like that. If they have the same number of crosshatches, then you, is it a crosshatch? Cross the line. The short little segment that intersects here. If they have the same number, then they're congruent. For instance, I could have put 3 here and 2 here. That would still indicate that these two were congruent and these two were congruent. You just match them up. It's an extremely primitive way to do it. I think people who don't even read and write could probably get the idea here that these two are the same when you put the two, when you put identical symbols right inside there. I think you've got it. There's a couple more types of angle pairs that you need to know about. They're also fairly simple. The first one, well, I might as well just use what I've already drawn here. Not only are these two supplementary, they're also called a linear pair. So you could quite legitimately write that linear pair implies supplementary. And boom, there it is written all out. And the implication goes both ways. No, it doesn't. You can't actually say that. You know why? The same as this over here. These two angles, written like this, they are both supplementary and a linear pair. However, suppose they were written this way. There's alpha 1, but there's alpha 2. These are not a linear pair. They're not on the same line. These are adjacent. That's what makes them a linear pair. And they're supplementary. So, if we were to say adjacent linear pair, then they would go both ways. But linear pair, that's this. It's not always supplementary. Pardon me. I'm confusing myself. I wonder where you're at right now. All I'm trying to point out here is that these linear pairs are always supplementary. However, it's possible to have two disconnected angles, two disjoint angles, two angles that are not adjacent, which are supplementary, but are not a linear pair. They don't share a vertex. Okay, have I managed to confuse everyone, including myself? Good. Let's move on. And here we get to something that's actually fairly important. This comes up all the time. Let's use our notation. What did I just write? I just said that these two angles are congruent and these two angles are congruent. And I should have turned these into lines so they look right. There we go. These two are called vertical pairs. When two lines intersect, the opposite angles are called vertical angles. It's a vertical pair of angles. I'm not sure why, because these two angles are also called vertical. We don't mean vertical in the sense of straight up and down. That's not the kind of vertical that we're talking about here. In this case, vertical just means these opposite pairs when two lines intersect, and they are always congruent. This angle measure is always equal to that angle measure. This angle measure is equal to that angle measure. These are called vertical pairs. It's important to remember that they're always equal, because when you know that, you can start doing a whole bunch of things, determining relationships between angles. For instance, if we had two lines here, pretend those are straight lines in parallel. If they're cut by another line, well, you can immediately start using some of these to figure out what the relationships are. For instance, this angle and this angle would be the same, this one and this one would be the same. And later on we could even find some other facts about these intersections that'll tell us about these angles too. We'll do that in a couple of videos. So here it is. Complementary. Complementary. Don't have to be connected. Supplementary. Supplementary. Don't have to be connected. Linear pair. They do have to be connected. vertical angles. Those are the angles produced when two lines intersect, and the opposite angles are equal. That's about all there is to this section. So let's do some exercises. There's a nice easy one. Two angles form a linear pair. Now what does that mean? Let's first draw it, just so we know what we're talking about here. Linear pair. There we go. And let's label them alpha 1. For algebra, I think it's easier this way. We could put A, B, C here, then D down here, and label them that way too. This is just shorter. Being a linear pair, we know that alpha 1 plus alpha 2 equals 180 degrees. And let's start out by writing down what you know. That's usually a good place to start. We also know that the measure of one angle is 4 times that of the other. And it's arbitrary which one is the larger one. They don't specify. So we'll just say alpha 1 is the big one. Pardon me, alpha 1 is the small one. So alpha 2 would be 4 times alpha 1. And that equals 180. Well, we add these up and get 5 times alpha 1 equals 180, or alpha 1 equals 180 over 5, which I think is 36. That's alpha 1. Alpha 2 is either 36 minus 180 from this equation, or 4 times 36. You can do it either way. I get 144. Now, if we add 36 back into that, are we going to get 180? I sure hope so. Yeah. So it all works. This is, well, I sure drew this wrong. Let's say that's alpha 1 and that's alpha 2. That way it might make a little bit of sense. Let's say that's 144 and that's 36. Not really scale. That's the idea. See? Pretty easy. All you had to do was set up the two things you knew. They'll lead to an algebraic equation which you solve. And then you're on your way. And as I've mentioned before, I like these error analysis problems. It's good to take a look at common mistakes. Here's a common mistake, I suppose. What did he do wrong? Well, let's see here. If 3x plus x equals 180, and 4x equals 180, and x equals 45, the algebra is okay. This is the part he got wrong, after all. This is a right angle, you know, because of that little square there. These are complementary angles, and they add up to 90 degrees. And that's quite a bit different. This is actually going to turn out to be about half of that 22 and a half. See, real easy. Just set it up right, and you'll get the right answer. Make a small mistake in the beginning, and everything after that will turn out wrong. Another example of paying close attention. Now here's one that's a little different from what we've done so far. They're asking you to find both x and y. Up till now we've only had one variable to worry about. So what do we do? Well, remember, it's probably mentioned somewhere in the book on the section on problem-solving approaches. There are no large problems. There are only sequences of small problems. When you get a big problem, break it down into a whole bunch of small problems, then you don't have a big problem anymore. We're going to do the same thing with this. Let's start by recognizing that these two form a linear pair. They are supplementary, and therefore they add up to 180 degrees. So we get that. And with a little rearranging, we get 16x pardon me, I just dropped my digital pen. 16x is going to be 160, and we divide that by 16, and I would say x equals 10. But let's check our work and see if that makes any sense. If x were to equal 10, this would be 70 degrees. This would be 90 plus 20, which is 110, and I think you can see those both add up to 180. So we're doing well so far. Now we could use some more algebra, I suppose, and like say, now that we know what this is, we could say this plus this is equal to 180. We don't need to. We know about vertical angles. We know that these two have to be equal. And in the process of checking, we already determined that this angle was 70 degrees. So this angle must be 70 degrees, which means y equals 35 degrees. Boom, done. Okay, here's another problem. More algebra. I know, this is a geometry class. Why are we doing so much algebra? Well, that's how math works. You just have to keep using all the stuff that came before. After all, you learned how to add and subtract a long time ago. But in every math class since then, you've used it, haven't you? Given these two angles, we're also given that A and B are complementary. That's supposed to say complementary. Someday I'm going to take a handwriting class. People will actually be able to read what I write. Until then, take my word for it. That says complementary. What does that mean? It means they add up to what? If you said 90 degrees, you were right. So, because of this, we can instantly just write angle A plus angle B equals 90 degrees. Well, now we just substitute, and we get 3x plus 2 plus x minus 4 equals 90 degrees. And rearranging all this, we get 4x minus 2 equals 90 degrees, or x equals 88 divided by 4, which I think would be 22. And when I started working this problem, I didn't even tell you what we were looking for, did I? When you see an x in an equation like this, it's a safe bet the first thing you're going to have to do is find x. That may not be what the question was, and in this case it wasn't. The question is, find the measure of A and the measure of B. Before we do that, we're going to have to find x, and that pretty much always turns out to be true. So 22 minus 4, that's pretty easy. That'll be 18. And 3 times 22 is 66, plus 2, I'd call that 68. Now, if we got this right, they'll add up to 90. And they're not going to. Made a mistake somewhere. Negative 16. I made a mistake. So let's see where it is. This is even better than those problems they put in the book. This is a real error. 22 minus 4, well, that's 18. And 3 times 22 would be 66, plus 2 is 68. So I may have made a mistake down here somewhere. Let's take a look. 3x plus x minus 2. Have you spotted the mistake yet? Well, 3x plus x is 4x. 2 minus 4 is minus 2. Uh-oh. I see. I did what students have been doing for thousands of years. I subtracted when I should have added. See, you're not the only one who does things like that. This actually should have been 92. And this should have been 92 over 4. And I think that would make this 23, wouldn't it? If I try that over here, what do I get? 23 minus 4 is 19. 3 times 23 is 69, and 2 is 71. Well, this is looking a lot better to me. How about you? 0, 1, 8. So there we go. An object lesson. Pay attention. Plus, I did an awful lot in my head. That's another bad habit. I've been doing it for a long time, so I do that, and I still make mistakes. If I had written plus 2 and then plus 2, this mistake never would have happened where I turned this into 88. But I did it all in my head and got it wrong. I hope you learned something from that. And let's try a very similar problem and see if I can get it right this time. A and B are supplementary. And once again, we're going to have to find x in order to find the measure of these two angles. What does supplementary mean? Well, that's the same as if we had written equals 180. Supplementary angles add up to 180. So now we just set up our algebraic equation. This is A here, substitute. So I get 10x plus 150 equals 180. Now I subtract 150 from each side. And get 30 equals 10x, or x equals 3. We put that back in here. We get 24 plus 100. That's 124. Over here we get 6 plus 50. That's 56. And they do, in fact, add up to 180. Hey, we got this one right. Cool. Well, let's try this one. You are given. We may not have to draw a picture, actually. We can do this pretty much with just algebra, I think. Let's give it a try and see how it works out. This angle here is a complement of RST. So let's start writing down what that actually means. In English, it's a complement. In real geometry, that means they add up to 90 degrees. So let's write it that way. Plus RST equals 90 degrees. RST is a supplement of ABC. So we have angle RST plus angle ABC equals 180. And what they want you to do is find the measure of ABC in terms of x. Since they haven't given you anything, it's going to be hard to come up with the actual angles, but you can come up with some relationships. For instance, if this is x naught, that's x degrees, pardon me, doing two different math classes at once here. X degrees, you'll see x naught later on in much more advanced classes. Pardon me. Okay, I went ahead and filled in a couple of things to save a little time. If we're going to refer to angle GHJ as x, as the measure, and did I do that wrong? Remember, you got to put the m in front of there to make sure that everybody knows you're talking about measure. The measure of angle RST is 90 minus x. We just rearrange this. We've got x degrees plus the measure of angle RST equals 90, so angle RST equals 90 minus x. In the second equation, we just substitute for measure of angle RST 90 minus x. Into this equation, we get this. So, what is the measure of angle ABC in terms of x? Well, pretty simple. 180 minus 90, which is 90. I'm subtracting, so let's do this right this time. 90 plus x. So whatever this turns out to be, angle ABC is 90 plus that. The main thing you had to do was set up the two equations. Use the information from one equation, find information, useful information from one equation, and this was what turned out to actually be useful right here, because then we take this part and substitute it so that this turns into that. Now we have the measure of ABC, angle ABC, in terms of x. Okay, these kind of problems always look long and complicated. You just have to break them down one at a time, take step by step, and see what it is we have here. Now, first let's identify angle FGB. Well, there's B, so that would be right along here and here. There's FBG. And BGC are supplementary. Well, there's B, G, and C. So that actually makes perfect sense. We'd have probably known that if they hadn't told us. And FGB equals 120 degrees. Explain how to find the measure of the complement of angle BGC. Well, I think the easiest thing to do would be to find BGC. Maybe I'm wrong, but these two are supplementary, and we know that this one is 120. So what we have is that 120 plus angle BGC, pardon me, the measure of angle BGC, equals 180. Or, this is a very easy one to solve. BGC, measure of angle BGC, equals 60 degrees. And it doesn't look too far off to me. So far the answer kind of makes sense. Now to find the complement of BGC, what would you do? What does it mean to be a complement? Well, let's say alpha sub C is the complement of this. Then we have 60 plus alpha sub C equals 90 degrees, or alpha sub C equals 30 degrees. See, it's not really that bad. First thing you have to do is draw yourself a picture. If you're using a book, rather than draw right in the book, it might be better to just redraw these lines as they are. Just redraw the important part, label it, and then identify the angles that they're giving you. Personally, I don't like writing in books. I think it's like disrespectful. Not everybody feels that way. Well, here's one that seems confusing at first. That's why they invented paper. It's much easier if you start writing down everything one piece at a time. For instance, the sum of the measures of two complementary angles. Well, let's just stop right there. Two complementary angles. So let's say alpha 1 and alpha 2 are complementary. In that case, they equal 90 degrees, don't they? Okay. Now the sum exceeds the difference of their measures by 86 degrees. Which means that the sum, that's alpha 1 plus alpha 2, exceeds the difference by 86 degrees. Well, what's the difference? Alpha 1 minus alpha 2 and alpha 1 plus alpha 2. They're saying that the sum, that's this, exceeds the difference. That's the difference. And what does it mean to exceed? 5 exceeds 2 by 3. It just means that 5 is 3 more than 2. So that equals 86. Now all we have to do is solve these two equations. Well, alpha 1 plus alpha 2 we know is 90 degrees. So we may not need to, but what the heck. Let's just put 90 right in here. We'll start by substituting. Starting out by using what you know frequently turns out a lot better. Now we have alpha 1, that's minus alpha 1, and this here becomes plus alpha 2. And that equals 86. So this tells us alpha 2 minus alpha 1. I got a negative alpha 1 over here and a plus alpha 2, so I just reverse the order and make it look a little bit more natural. Subtract 90 from each side. That equals minus 4. So what we have here is alpha 2 equals alpha 1 minus 4. But we can put that back in here now. For instance, the alpha 2 is alpha 1 minus 4. So we substitute that right in here. Equals 90. And that'll give us that 2 alpha equals, add 4 to each side, or alpha equals 47. Well, again, we can use this equation. If alpha 1 equals 47, then alpha, whoa, I should have put a 1 in there, shouldn't I? Alpha 2 would be 90 minus 47, or 43. 43 33 and 47. Does that add up to 180? Well, let's take a look. With luck, they do. They better not add up to 180. I'm going backwards here. They're supposed to add up to 90. Let's see if they do. And they do. So you see, this wasn't so bad. You just had to break it down. When they say that these two angles are complementary, write that down right away. Because they just told you something, so write it down. This one, well, you just have to understand what it is they're trying to say. Difference, that pretty much always means subtraction. You can pretty much always replace the word difference with the word minus, or subtraction. When they say the difference of two measures, that means you subtract one from the other. And that's what you get. That's how we set this up here. We took the sum and subtracted the difference. I know that subtracting the difference sounds weird because we're subtracting twice. Difference here means the difference between these two, but then we have another difference, which is the difference between the sum and the subtracted quantity, if you want to call it that. And that's equal to 86. That gave us this equation, which led to an expression for alpha 2 in terms of alpha 1. Remember, with one equation, you're going to have a hard time solving for two variables. Sooner or later, you're going to have to find one variable in terms of the other and substitute it back in. Now you have one variable here. This is what allows us to actually come up with a number for one of these. In this case, alpha 1. Didn't write it down, did I? There we go, alpha 1. So, wasn't too bad, was it?